First, you work with either cross-sectional data or time series data. Cross-sectional data means that you observe different objects or within single period of time. For example, survey of students. We conducted one survey. We surveyed different students within one day. It's a cross-sectional data. Time series data, we observe one object over different periods of time. For example, stock market data. Well, we could observe stock price movements for Apple company for 5 years. It is a time series data. And usually you cannot apply tools for cross-sectional data analysis to solve different time series problems, to analyze time series. Well, but for sure there are some certain solutions how to work with time series data using conventional and so usual statistical tools. Well, next. Imagine that you made a decision whether your data is cross-sectional or time series. And imagine that your data is cross-sectional. What else? What is next? You have to make a choice, or you have to understand whether you analyze whether you work with qualitative or quantitative data. And now we have to speak about variables and scales of measurement. What is your scale of measurement and what type of variable you have? It is also important because choice of the right statistical tool depends on your understanding of the data. And we have two classes of variables. First class is qualitative variable. For example, gender, level of happiness. Are you happy? Yes or no? Or rate your level of happiness from 1, I'm very unhappy, to 5, I'm very happy. It could be your education level, high school, vocational training, university degree, postgraduate degree, and so on. Well, or your variable could be quantitative variable. For example, it is price, weight, age, length, distance, speed. Well, I think it's fairly easy to understand what kind of variable you have, qualitative or quantitative variable. Well, so usually when we observe persons or firms, we collect all types of variables. We collect both qualitative and quantitative information. For example, imagine that you survey firms to understand the relationship between return of assets and firm size. In this simple case, you should collect information about return on assets, information about total assets, information probably about sales, and all of these variables are quantitative because they are measured using dollars, rubles, or euro. Well, but also it could be important to collect information about industries. Well, so industry could be oil and gas, manufacturing, finance, agriculture, and so on. And this information is qualitative. Also, you can collect information about CEOs, whether your CEO is female or male, whether your CEO has MBA degree or any international experience, and all of these pieces of information make qualitative variables. All of this information is qualitative. And You can easily find both types of variables if you open all data. I think if you open any data set in the web, it could be census data, it could be firm surveys, it could be a policy poll, and so on. For example, you know that in the mid of September we have elections to the State Duma, and different companies conduct surveys about opinions, and for sure they could ask questions about your preferences over candidates, and this information is qualitative, well, but in addition they collect information about your age. It is definitely quantitative information. Sometimes it is unclear so it could be unclear for a student what variable we have. But for example, income. Income could be, by the way, both qualitative or quantitative variable. So it depends on the variable itself. Example, if I ask respondent about his or her income, this person could tell me a single number, for example, $1,000. And this information definitely is quantitative information, and this variable should be quantitative variable. But there is a problem with such a question. Often people don't know the income. Imagine a very rich person, and so high income persons usually don't know the income, or they don't want to tell the amount of income. And in this case, interviewers often ask qualitative questions. For example, could you rate how rich or how poor you are? Or they could offer to choose intervals. For example, your income is between $0 and $1,000, or between $1,000 and $2,000, and so on. And in this case, in the latter case, we work with qualitative variable. Again, to sum up, remember that variable could be qualitative if you measure something qualitative. It could be gender, education, it could be your marital status, or quantitative variable. It could be age, it could be sometimes income, it could be weight, it could be length, body mass index, everything we can easily measure. Well, what else? Inside qualitative and quantitative variables, we also have certain classes of variables. First, in quantitative variables, well, there are discrete or continuous variables. Well, no, first, let's take a discrete variable. The intuition is simple. It's a whole number. For example, number of family members. It's impossible to imagine a family with 1.5 family members or 2.5 family members. It could be 1 or 2 or 3 family members, but it cannot be 1.5 or 2.5. Well, also, but it doesn't necessarily mean that discrete variable is always a whole number. Imagine a price. For example, stock price can take value 2.37 or 2.48. Doesn't mean that this variable isn't discrete. No, it also discrete, because it's impossible to find a price 20.37156, or it is impossible to find a price equal 20.38256. Well, your price would be either 20.37 or 20.38. Highest your price usually have no more than 2 decimal points. And in this case, you also work with discrete variables. And by the way, often when we work with variables measured using dollars, euro, rubles, we work with discrete data, because so we could get just 2 decimal numbers. Well, in addition to discrete variables, we have continuous variables. Continuous variables are they could have the unlimited number of decimal points. For example, discrete number could be 100.3, 100.625, 100.8342, and so on. Well, imagine of continuous variable is weight, is distance, it could be maybe speed. Well, and so, but also we could apply discrete terms to express a continuous variable. So, for example, newborn's weight could be 6 pounds 10 ounces, and another newborn's weight is similar discrete terms as 6 pound 11 ounces. Well, no, fortunately, so when you want to apply certain statistical tool, you shouldn't distinguish between discrete and continuous variables, but sometimes we should. And today, by the way, we have to learn a case when we have to make a decision whether we work with discrete or continuous quantitative variable. It is very important when we create different frequency distributions or relative frequency distributions. In addition to quantitative variables, we have qualitative variables. Qualitative variables are interesting. They could be binary. Well, for example, they could be nominal. No, binary variable, by the way, is a special case of the nominal variable. And let's discuss nominal scale in greater detail. What does it mean, nominal scale? It means that you have different pieces of qualitative information. For example, brand names or company names. Look, but in this table we have 4 columns. Or 2 variables. First variable is a company name. Second variable is stock exchange name. Both columns show qualitative variables, and these variables are nominal because it doesn't matter. So you can't order these rows as you want. Well, it doesn't matter. And moreover, there is another interesting piece of information regarding nominal variables. Well, look, you have qualitative variable, and now you look at the text. But in statistics, we don't analyze text itself. We analyze numbers. And one could ask me, okay, we have tags, but how can we transform these tags into numbers? Well, and in order to analyze qualitative variable, we use special codes. For example, we could say that, well, New York Stock Exchange means that our variable equals 1, and NASDAQ means that our variable equals 0. In this case, the program reads this column as a set of 1 and 0, 1, 1, 0, 1, 1, 1, 0, and so on. The program, in this case, the program reads this column as a numeric column. Well, and the same logic can be applied to this variable. We could use a code, for example, for 3M, we could set number 9, for American Express, we could set number 10, and so on to analyze such data. Let me show you a simple example in Excel, how to illustrate how all of this stuff works. Well, wait. Yeah, look, imagine that, variable 1. For example, we conduct a survey and we collect information about marital status. A person can be married or single. Well, for sure it is impossible to analyze such a variable because it is a text. It's impossible to calculate percentage of married persons in our survey. Well, and to make our analysis possible, we should use codes. For example, we should set married persons. We should set 1 for married persons and 0 for single persons, and so on. Well, yeah. And in this case, if we use such codes, we can analyze such a variable. Well, for example, in this example, percentage of married person is 0.5. The same logic is applied to other nominal variables and, by the way, ordinal variables. Well, and let me show you another example and this example is about real data set. Let me open. Just look, you don't have to do this. Let's set larger font. Look, this is a real data set in a professional statistical program state. We will use this program later. And what we have here, well, we have qualitative variable. It is the name of producer. We don't want to analyze such a variable. And because of this, we don't use codes. Well, let me show. Look, if I double click on this cell, the program shows me a text, but there is a qualitative variable I want to analyze. For example, this variable shows whether this object is produced domestically or whether this product is foreign one. And in this case, I look at words, domestic, foreign, but behind these words I have numbers. Look, if I double click this cell, program shows me 1. If I double click domestic, program shows me 0. Why? It means that this program doesn't read this column as a text data. It reads this column as numeric data. And because we set 1 for foreign and 0 for domestic. Well, and by the way, we have here a lot of quantitative information, quantitative variables. Well, what for example, price is quantitative variable here. Well, next, tell me please in the chart, type plus if you understand how program reads nominal data, and minus if I have to explain it again. Type in the chat whether you understand the idea of nominal scale coding or and minus if you don't understand. Okay, I see different answers, minus and pluses. Look, okay, again, look, do you have a variable? You work with qualitative variable. But imagine you work with qualitative variable and your variable shows marital status. Person can be married or single. Well, but imagine that we collected such a data. We wrote whether this person is married, whether this person is single. Everything looks good, but there is a problem. If I count average, for example, simple statistical tool, average. Excel says nothing. Excel says that there is an error with my data. Why? Because this data isn't numeric data. We can analyze in statistic numeric data only. Well, and when we work with qualitative variables, we have to transform our qualitative values to numbers. Look, it is qualitative information, piece of qualitative information. And our job is to transform this text into number to analyze such a data. And to transform this text into number, usually we rely on a very simple logic. When our qualitative variable has just two possible values, for example, married or single, female or male, we actually replace or create a new variable, and this variable has numbers, and one number should mean one piece of qualitative information. For example, one means that person is married, and 0 means that this person is a single one. Well, and when we create such a variable, we can analyze it, we can easily calculate, for example, proportion of married persons. It works. And what you have to understand that always when we work with qualitative variables, we should transform qualitative information, i.e. text, to numeric information, i.e. we have to make numeric variables using qualitative variables. This is the idea. Another example, to make it as clear as possible. Imagine that we have a variable 2. This variable shows education level. So, for example, MBA, Bachelor of Science, Master of Science, and so on. Well, variable 2 is also qualitative variable, and this variable has 3 possible values: MBA, bachelor degree, master degree. Well, and this variable itself, it is a text variable. We cannot analyze text using statistical tools at a basic level, at least. And we have to transform this text. We have to do something to obtain numbers. And what should we do? We should make a decision. We should assign different values to different pieces of information. For example, I would like to assign 1 for MBA, 2 for bachelor, and 3 for masters. Probably you would like to use all the values. For instance, 10 for MBA, 100 for bachelors, and 1 for masters. Doesn't matter what variables you assign to these cells. What is important? So you cannot assign different numbers to the same piece of information. You cannot say, here I want to set 1, here I want to set 10, and here I want to set 1000. No. This is a wrong strategy. One word, one number, and you have to use the same number for the same words. Well, is it clear now? Type plus or minus. Yeah, Valerie, about your question. Well, usually professional statistical programs like RStudio, Stata, SPSS, they do this job automatically. And by the way, if you download a real data set of a real survey, this job is done. So in most cases, this job is done well, and you don't need to assign your own numbers to different pieces of information. Well, But if you work with Excel, you have to do this. Daniel, yeah. After the converting the qualitative data into the numbers for future use, is this converted information still qualitative data or not? Yes, definitely. Please, all of you remember that even if I create numbers, still it is qualitative variable. Still it is qualitative variable. Why? Because this variable still reflects a qualitative phenomena. One means married person, single means single person. Well, you cannot, for example, one means MBA, two means bachelor, and it doesn't make sense to find a difference between, for example, one and two. This number is useless and senseless because our data is nominal qualitative data. Well, still it is qualitative data. And one point more. What is the future of the nominal scale? Both variables, by the way, no, actually reflects nominal scale. No, maybe education is less, but could be. Well, no, let's make not education, maybe majors. For example, econ, management, and social science to make the analysis maybe easier for you. What imagine that you have two variables, both of these variables are qualitative. Well, we use numbers to analyze these variables, but these variables rely on the nominal scale. What does it mean, nominal scale? It means that the order of these numbers doesn't make sense. You can set here -1, 0, 1, and so on. Doesn't matter. Doesn't matter. Well, what matters, you have to assign single number to all words which are the same. Well, the order of these numbers doesn't matter, and it is a nominal scale, and this is the reason why this is a nominal scale. And another explanation, you cannot compare actually, or it is very difficult to compare objects in your data. For example, well, it's very difficult to say what to explain. So you see that this person, his major is economics, major of this person is management. Okay, if I calculate the difference between -1 and 0, can I interpret this number? Does this number make something, show us something interesting? No, it's absolutely useless and senseless number. Well, what we can say, looking at nominal scale, we can say that, okay, this person has, so works on economics degree, this person works on sociology degree, this person works on management degree, and so on, but it doesn't make sense to compare. But if we work with quantitative variables, for example, it is age. Students, well, we can compare our students in the data set. Well, we can say that, okay, so the difference in age between student number 1 and student number 2 is 1. Well, it could be, but when we work with nominal scale, any cross-sectional comparisons are useless and senseless. Well, so next. Next is the ordinal scale. Ordinal scale is used when we rate something. For example, level of happiness. You can rate whether you are very happy, meaning 5, or you are very unhappy, meaning 1. Well, you can set 2, 3, 4, but you cannot set 2.5, 2.1, and so on. Well, and in this case, there is some order inside your qualitative variable, for example, 1, 2, 3, 4 here. And you see that 4 is bigger than 1, and it means that, so for example, so this answer is excellent, this answer probably is better than this one. Well, the same can be said about good and fair. Well, in this case, we can say that, so we can a little bit compare persons. We can say that, for example, this person has excellent marks, this person has maybe poor marks or poor performance. So, and the performance of the first person in our example is better than that of the last person in our sample. Well, it could be. But what is very important, what is the most important difference between ordinal and nominal scale is that in nominal scale, what the order of these numbers and these numbers doesn't make sense. But in ordinal scale, it makes sense. Well, in principle, but yeah, one important remark. Well, we can say that, for example, no, imagine that this variable shows performance of a student. Excellent, good, fair, poor performance. Well, we could say that, for example, performance of the first student is definitely better than performance of the last student. But the difference between 4 and 1 also is useless and senseless. This is a tricky point. Look, let's create variable 3, variable 4. But imagine that we have excellent, good, fair, poor. Performance. Well, and 4, 3, 2, 1. Well, I can say that performance of this student is better than performance of this student. What's the difference? Well, we cannot interpret it. It doesn't make sense because here I can use another number, for example, 20. What matters? This number should be bigger than other numbers for other answers. That's it. Well, and for sure, if I replace 4 with another number, the difference should be bigger. And so, again, it doesn't make sense to analyze such a number. Well, to sum up, guys, when we work with qualitative variable, we can work with either nominal or ordinal scales. In nominal scale, doesn't matter what numbers we assign to pieces of qualitative information, order of these numbers doesn't matter. I can set here, for example, 0 for married and 1 for single persons. Well, and still this number is qualitative and still this number is nominal 1. Doesn't matter. The same can be said about the second variables. In ordinal variable, well, the order matters. Well, I can set here, for example, 10, 9, 8, 7, well, but it could be so and so on, but it could be a mistake set here, for example, 7, 8, 12. Well, what? You shouldn't do that. If you work with ordinal scale, you should type, for example, 1, 2, 3, 4. It could be because there is some order inside your variable. You could use another order, another numbers, but you should keep some order inside this variable because it is an ordinal scale. Well, No, here you can read some maybe notes about this one. So next we have interval scale. Interval scale, no, by the way, it's a very rarely, this scale is rarely used in management, but anyway, probably you can use it. In interval scale, we work with, we can categorize or run the data. Well, and we also assured that differences between scale values are meaningful. Well, arithmetic operations are meaningful, and a typical example of interval scale is Fahrenheit scale or Celsius scale. And what is a key feature of an interval scale? In interval scale, we can obtain value equal of 0. Well, but it doesn't mean that if our interval scale is 0, it doesn't mean that this phenomena doesn't exist. For example, temperature. Today is 0 degree, so I use Celsius scale, but it doesn't mean that temperature doesn't exist. Well, because if I apply Fahrenheit scale, my temperature cannot be 0 degrees. Well, and it is a drawback of interval scale. And by the way, it is very difficult to find example or another examples, well, for interval scale. A more convenient scale is a ratio scale. Well, ratio scale, it is the strongest level of measurement. Well, and when we have ratio scale, we could apply different arithmetic operations. It means that differences exist, and usually most of continuous variables, discrete variables, they rely on ratio scale. For example, sales, profits, inventory levels, they are ratio data. Let me show you my data set. Look, it is qualitative data. This this variable is a nominal variable because it doesn't make sense whether I use 1 or 0 to denote foreign or domestic. But other variables in my data, they are quantitative. Well, they can be discrete. No, most of them, I think, discrete. They can be continuous. For example, weight and length. Well, and all of these variables, they rely on the ratio scale. Well, um, so it means that I can find differences in prices. I can, well, find average prices, so it makes sense. Well, I can compare prices for different objects. Well, it makes sense. Well, and if I have 0, I can also interpret it usually that this product is sold for free. Well, so meaning that there is no any actual price probably. Well, remember that in qualitative data, usually arithmetic operations are useless and senseless. But when you work with ratio or interval scale, you can apply arithmetic operations, as you can compute differences among values. Well, and last piece of information about different types of variables. Please remember that quantitative variable could be continuous, and often in statistical packages we use synonymous to denote that this variable is a continuous one. We could say that this variable is interval, float variable, numeric variable, while for discrete variables we often say that it is integer variable or count variable. Well, you will see it later when we will work with data. Also, when we work with qualitative variable, this variable could be categorical. For example, or synonymous of this variable, enums, enumerated factors, nominal, variable. Well, it could be binary variable, for example, true, false, married to single, female or male, and so on. Another name for binary variable is dichotomous variable, logical, indicator, boolean. Well, and or variable could be ordinal or ordered factor. Well, that's all about different variable types. To sum up, what you have to keep in your mind always when you work with data, you have to distinguish between qualitative and quantitative variable. Well, this is very, very important. Next, if you work with qualitative variable, you have to distinguish whether this variable rely on nominal or ordinal scale. Well, and if you work with quantitative variable, so sometimes it makes sense to distinguish between discrete and continuous variables. Sometimes it doesn't make sense. Well, but what you always have to do, you always have to make a clear distinction between qualitative and quantitative variable. If you cannot do this, you cannot do good statistical analysis. Well, please remember this. And for sure, you have to understand whether you work with time series or cross-sectional data. Well, next is this. So next we have to discuss. We have to start our discussion, and this discussion is about descriptive statistics. Well, what is the idea of descriptive statistics? Let me stop the presentation. I would like to explain it as clear as possible. Well, often when you work with data analysis, often you work with descriptive statistics. What does it mean? It means that you want to describe the whole data set using charts or numbers. I often use a following metaphor. Imagine that you want to watch a movie, and so you don't know whether this movie is good or bad, whether it is boring or interesting. Well, and you would like to ask your friend who have seen this movie. Well, and this friend can say, this movie is boring, or this movie is very bad, or this movie is bad. Look, your friend doesn't provide you with spoilers. Your friend doesn't explain explain everything in detail related to this movie or cinema. Well, your friend used just a single word: boring, good, bad, okay, so, or average, single word to describe the whole uncomplicated phenomena. Well, because probably some episodes are very good, some episodes are very bad in the movie, maybe there are some fuck-ups in this movie, and so on. Well, it is very difficult to use a single word. And by the way, for sure, when we use a single word, we lose a lot of information. And this information could be also interesting and important for the reader or for the audience. But this could work. Usually we say, well, this movie won a lot of Oscar awards. Probably this movie is a very good one. While we use short phrase, very good, to express our idea, so our emotions about this movie. And the same can be done in statistics. We can do this in statistics while using numbers. Imagine that you have a variable. This variable is quantitative. It is say discrete variable. And this variable is about age. So 1, 2, 3, 4, 5 use age. Well, How can we describe this variable using a single number? Well, we can calculate the average age, or we can create a chart. We can create frequency distributions to describe what we have. And any good statistical analysis, I recommend to start your statistical analysis with charts. It makes sense to look at your data. And now we have to learn how to create a simple frequency distribution and charts and tables in Excel. Well, so again, what we have? We use graphs, charts to describe your data set. And first, and the simplest tool is a frequency distribution. Well, imagine that we have a set of data. For example, in your data set, you have 6 variables. Well, no, actually you have 7 variables. First variable is ID of salesperson. Well, and you have number of cars sold in each region. For example, this person sold 5 cars, the same person sold 2 cars in region 2 and 9 cars in region 3 and so on. And I would like to describe such a variable using frequency distribution. How can I use this? I can create a frequency distribution chart. Well, or I can create a frequency distribution table. It looks like this. Well, I can count how many salespersons sold nothing, how many salespersons sold 1 car, 2 cars, and so on. Again, this table shows how many salespersons sold, for example, 9 cars, 8 cars, 7 cars. For example, I see that 2 salesperson in region 1 sold 5 cars, 5 salespersons sold 4 cars in my sample, and so on. Well, and now in Excel we have to do this job. How to create a frequency distribution chart? Well, let's do it together. Oh, wait. So first you should find minimum and maximum values. I hope you know formula min. Please find a minimum value in cars region 1 and maximum value. What is your maximum? 3 and 9. Please find these 2 numbers for region 1. Ready? Type plus if you are ready. Look, here I use min function. Here I use max function. Good. Next you have to make a table. First variable is number of cars sold. 3 is your minimum value. 4, 5, 6, 7, 9. It means that you want to count how many salespersons sold 3 cars, how many salespersons sold 4 cars, how many salespersons sold 5 cars, and so on. Well, by the way, if you want, you can use more numbers, 10 or 2, 1, 0, but it doesn't make sense because, well, in this case, so you will get 0 salespersons, but you can use it. It's not necessarily a mistake. And number of salespersons. And next you should apply a simple count if formula. You should count well, how many salespersons sold free cars. Don't forget to freeze up your range. Yeah, by the way, one row means one salesperson. Apply this formula to count how many salespersons sold a certain number of cars. Well, do you have the same output? Type plus. Good. Well, next, it is a simple frequency distribution chart. Well, but we can apply such a tool when we analyze a single variable. But if you want to compare two regions, for example, region 1 and region 2, well, you cannot use such a strategy because, well, look, I have now in region 2, probably, no, say in region 3, I have more salespersons. Well, look, in region 3, I have more salespersons, and because of this, my numbers should be higher. Look, for example, region 1 and region 3. Let's make its frequency for region 1, and let's make a frequency for region. Now, please create a frequency table for region 2. Again, you have to find minimum value. Look, your minimum now is different. So and again, you have to apply the same logic. Count if, select the range, and apply the criteria. Check whether you have the same numbers. Type plus if you have the same output. Look, now let's make a histogram. Well, no, we have to use 2D column chart. Well, next we should, in this chart, set that our x-axis is number of cars sold. Let's put it here somewhere. Well, select data. And look, first variable. We can say that our values are this one. like this. And let's series name is frequency region 1. Well, next series 2. And this one. Well, and for these values, we can use this one. Look, create the same chart, please. Type plus if you are ready.
Sorry, can you move it to the values?
Sorry, I can hear you. Well, probably there is a problem with the signal.
I know. Can you hear me?
I am trying.
And now?
Now is better.
Okay, thank you. Can you please a bit move it to the values of the table? There are all these things, like frequency.
Could you please repeat, because some of...
Can you please move your screen a bit higher?
Yeah,
From
yeah,
the
yeah,
graph
yeah.
to the
Yeah,
table.
yeah, yeah. Look, this one. Well, now when other students are working on the chart, let me explain what happened. Here we have a problem. Look, it is very difficult to compare these two columns. Well, we can say that, look, if we look at our chart, we can say that performance of our company in region, no, it's not region 2, it's region 3. In region 3 is better than that of region 1, because our bars are higher than these bars, but it's not necessarily true. Because in region 3 we have more persons, and because of that we have higher numbers here than in this column. Well, and please remember, if you want to compare to frequency distribution, you cannot rely on a simple frequency distribution. You have to rely on a relative frequency distribution. What does it mean, relative frequency distribution? It means that here we count how many salespersons we have. But in relative frequencies and proportions. Well, to count the proportion, you have to find sum of all salesperson, 19. Well, indeed, so look, we have in region 1, 19 salespersons, and sum of these values must be 19, otherwise it is a mistake. Here we have 78 salespersons, and if we count all observations in our sample, we can see that so our answer is 78. Well, and how to calculate it? We should just divide this number by the total number. That's it. And that's it. Well, just a simple division procedure. And you can apply the same logic for your look. Divide first cell by the total row. Don't forget to freeze up your total row totals or total cell and calculate proportions. And once you have such values, look, this is a formula, but you can compare these frequency distributions. Please change your chart. Look, I would like to do this one. First, I would like to move this range to this column. I would like to move this range to M column. And now, when my chart is relying on relative frequency distribution, I can compare these distributions. They are comparable now. Well, maybe it makes sense to add legend. Type plus if you have the same chart now. Look, just move your ranges from this column to this column. Just drag and drop them. Should I wait a little? Well, good. Look, what we have, if we look at this chart, what we can find. Look, first, look at the orange bars. It is an example of a bell-shaped distribution. What does it mean? It means that shape of this distribution is like a bell. We have a single peak somewhere in the middle, and we have a small increase from the left side to this peak, and next we have a small decrease from this peak to the right side, to the maximum value. Well, and by the way, most of our variables follow such a distribution. Your marks, your weight, income could be, well, follow such bell-shaped distributions. But sometimes your distribution could have two peaks, and this distribution is an example when we have two peaks. For example, we see that, how can we interpret them? It means that in region 1, there is a large group of salespersons whose performance is below the average or below the middle level. And we have a group of very good salespersons whose performance is high. Well, if I look at region 3, I see that it is a typical case when most of my salespersons demonstrate typical and average performance. Well, so there are nothing interesting in region 3, but in region 3 I see that there is a large group of salespersons with low performance, and there is a large group of salespersons with high performance. Why I say large groups? Because these bars are very, very high. It means that there is a lot of salespersons selling 4 cars and selling 8 cars. Well, and my managerial decision is to do something with region 1 because I need to do something with this problem. I have a lot of low performing salespersons, and do nothing with region 3 because it is a normal case. Well, so this example illustrates how can we use a simple frequency and relative frequency distribution to make a managerial decision about performance of our salespersons. Anyone, could you please turn off your microphone? Well, next. But what if you have a continuous variable? Well, what if you have a lot of discrete values? Look, in our example, our minimum value is 2, maximum value is 9. Well, and in total we have 8 possible values, or we can create 8 possible bars in histogram, in frequency distribution histogram. But what if we have, for example, 50 possible values or 1000 possible values? Can we use the same tool? Can we apply the same logic? Actually, no. Or what if we want to analyze information about our sales? Well, can we apply the same tool? No, because each value in this range is unique. Well, and if you apply the same logic, your column, your frequency distribution should be full of the same values, 1, 1, 1, 1. It doesn't make sense. How can we solve such a problem? Well, and here I would like to illustrate in brief the strategy. Well, first, you have to group your variables into classes, or you have to define classes. It looks like this. I want to count salespersons whose performance is between $0 and $1,000, between $1,000 and $1,000 and $2,000, $2,000 and $1,000 and $3,000, and so on, and so on. I have to create such groups. How many groups I have to create and what size of this group is an interesting question. Size means a difference between 0 and 1000. So between here, for example, my size is $1,000. You can set your own size. Well, but there is a question. How to find right size? How to find right number of groups? Because if your size is large, group number must be small. If your size is small, group number must be large. How to define it? First, you should check whether your class is mutually exclusive, all-inclusive, and equal width. Usually we use classes with equal width. So if my size is 1000, it should be the same for all classes. I cannot use here size, for example, $2,000 or size is $3,000. Never do that. It's a mistake. Your size always must be the same, but there is one interesting exception. Next, mutually exclusive. Your sizes cannot overlap one another. You cannot set here from 0 to 1000, from 1000 to 2000, because it is unclear. Okay, if my salesperson shows $1,000 of sales, should I count it here or should I count it here? Unclear. If your classes aren't mutually exclusive, well, you can get such a problem. All inclusive. Your classes must cover all possible values in your range. Well, if I stop here, if I use just 3 classes, I miss a lot of information. Well, because someone shows, for example, $10,000 performance, well, I will lose these persons and my analysis cannot be complete. Next, you have to define number of classes. Usually we apply a very simple logic. We apply such a formula where n is the number of observations in your sample and k is an arbitrary number from so you can set, by the way, any number. Well, or you can define your own number of classes. Usually this number is between 5 and 10. Well, no, let's calculate number of classes using such a formula. Well, to do this, you have to count how many observations you have in your sales region 1. $19 is N. Next, you have to set K and keep this cell empty, and 2K is 2 times this one. And you have applied such a formula. Look, for example, if I set K1, so my output is 2. If I set K5, my output is 32. 32 is definitely bigger than 19. Well, and K here is the number of classes. I can use 5 classes, or, well, can I use 4 classes? No, because 16 is smaller than 19. But I can use 6 classes. I can use 10 classes, but probably 5 is fine. Well, or you can set your own arbitrary number of classes. Next, once you make a decision about number of classes, you have to make a decision about class size. To find so the class size, you should apply such a formula. You should find a difference between the maximum value, largest value in your sample, and smallest value in the sample, and divide it by number of classes. Number of classes could be K, or it could be your own number. Well, and this value, by the way, could be so with decimal points. Oh, let's calculate class size. Max of your sales minus min of your sales divided by, look, 5. This is the formula I use to define class size. Please, just look, don't do the same. Just look what I am working on, what I am doing. Look, what does it mean? It means that my first class must be from 0 to 3, 5. It could be from 0 to 3, 5, 8, 4, 1, 3, 9, 9, 4. It's very, very inconvenient to use such a class size. And to make our histogram easy for interpretation, we should either round up this number. We could use instead 3, 5, 8, 5. But it's also very inconvenient. Or we could set maybe a value which is bigger or a little bit smaller. It could be, for example, 4,000. My class size could be from 0 to 4,000, or it could be 5,000 even from. Well, why? Why I use such a numbers which are close to my output, but still they are different, and these numbers for sure aren't consistent with a typical arithmetic rule of rounding. Because if you rely on such a class size, it could be very, very inconvenient to interpret your histogram. But your histogram must be convenient for interpretation. And to make it convenient for interpretation, you should use larger class sizes. Well, and once you define class size, you should identify ranges from, for example, and so on. Well, and so on. And you should count how many salespersons falls this range, how many salespersons falls within this range, and so on. And once you count all of this, you can create frequency distribution chart or relative frequency distribution chart. Well, that's it.
Question.
Yeah.
Excuse me. Is it fine that in this table that you have just created, in the first part there is from 0 to 5,000? That means that there are 5,001 numbers, and in the second part it's 5,000 to 10,000, which means that 5,001 to 10,000, which means that there are one number, 1 point less.
No, remember, your classes cannot overlap one another.
Mm-hmm.
If they cannot overlap one another, everything is fine. And also you should cover all possible values. If you miss something in the middle, it could be a mistake.
So they are not supposed to be equal. There can be one.
No, usually they could be like this, for example, so 0, x must be greater than 0 and no greater than 10. It could be like this. Well, for sure it could be like this. It could be like this. What approach to use is your own decision. Just what you have to do, you have to check these 3 rules, whether your class is mutually exclusive, all-inclusive, equal with. That's it.
Can it be called equal width if in the first class there are 1 point amount of points is one bigger in the one than in the others?
If the first point is bigger.
I mean that it would be equal width if it would have started from the first to 5,000.
First to 5,000. Could be. It's not a mistake. It could be. Remember, to sum up information about frequency distribution, I know that our time is up. Your frequency distribution must be easy for interpretation. You can set your own number of classes. You can set your own class size. If you want to relate to this formula, okay, no problem. But you can set your own class number of classes, class sizes, but your frequency distribution must be as so very easy for interpretation, like this. Well, that's it at home. So your home task is to create a relative frequency distribution for these 3 variables. Well, I will send you now my lecture notes with the home task and some tips how to use what formula you should create in Excel to create to make such a chart. Okay.
Quick question: should we upload our homework somewhere?
No, this week no. Yeah, about what we expect next week. Next week you have to be very good in making different frequency distributions. You have to be able to create simple frequency distribution for discrete data. You have to be able to create frequency distribution for continuous data. You have to be able to compare distributions using relative frequency distribution. Well, in addition, you have to be able to distinguish different data types, scales of measurement, and variable types. Well, no, first we should start with theory. We should check whether you understand whether a variable is quantitative, qualitative, so on. Next, we should check whether you can create frequency distributions. Well, and this week you have to do a lot of exercises. Most exercises have answers in your textbook. Well, check whether your solution is correct, please, because in the seminar we can give you maybe some exercise and you have to demonstrate that you can solve such an exercise. That's it. Questions? Well, okay, it seems no questions. So thank you for your attendance. And next week we have to learn more about descriptive statistics. See you next week. So on Monday and Tuesday. Good luck.
Thank you. Goodbye.
Thank you.
Thank you, goodbye.
Thank you. Bye.
Thank you.
Евгений, простите, у меня вопрос один.
Ага.
Вот, у меня вопрос, он не больше контента лекции касается, а больше именно...
Я запись отключу, там, наверное,